Multiplying matrices. This is very different than adding. Adding matrices is the easiest thing in the world. You just add corresponding parts. Multiplying matrices, you do not do that. Rule 1, do not multiply corresponding parts. That is not what you want to do. Multiplying matrices is a lot more complicated. We got to find if things match and then multiply it accordingly. So the first step about actually multiplying matrices is see if you could do it, because not all matrices can be multiplied. What you want is when you multiply matrices, you want to see if the inside rows match. Let's say I want to multiply a 3 by 2 by a 2 by 1 matrix. The first thing we're going to do is we're going to check the middle inside 2. The row of the first matrix times the column of the second matrix. If these match, then you can multiply. Yay, happy face. And then what happens is the entry you're going to get is going to be the outer matrix. It's going to be a 3 by 1. If I multiply a 3 by 2 matrix by a 2 by 1 matrix, I get a 3 by 1 matrix, which is interesting. However, what's even more interesting is that sometimes you can't even multiply a matrix by itself. If I get multiplied by another 2 by 3. In this case, the middle two do not match. It's actually you can multiply, no solution. Our first step in multiply matrices is to see if you can multiply a matrix. The middle two have to match. If they match, then you can multiply it, and you get the resultant matrices, the outer ones. That's what this is saying right here. Let's do some examples. Just to see if we can multiply. That's all we're caring about right now. This is the first one. A 4 by 6 times a 6 by 2. All these insides match. Yay. And then we get a 4 by 2. We can multiply, and I'll get a 4 by 2. Look at the next one. 3 by 2 times a 3 by 2. These do not match. No solution. Can't multiply. Not possible. It's probably the better answer. There's not really a solution. Anyway, so that's step 1. Just see if you can multiply things. This is why you don't just multiply across. If you just multiply across a 3 by 2 times a 3 by 2, you would get an answer where you're not supposed to. That's why we do not multiply across. And let's talk about how we do this. I'll kind of show you 2 ways. The first way is the proper way, which is I have this matrix here. Best is to do by example. We'll do 3, 1, 0. And then we're going to multiply by this other 2 by 1 matrix. 3, 4, negative 1, 2. The way we multiply is this. We multiply the rows of the first matrix by the columns of the second matrix. Everything in matrices is row by columns. When we multiply, we're going to multiply the rows of the first matrix by the columns of the second matrix. And actually, step 1, let's make sure we can multiply these. The 2 by 2 times the 2 by 2. These do match, and I get 2 by 2. What I like to do is actually draw out the 2 by 2. Here's my 2 by 2. Row 1, row 2, column 1, 2. I'm going to get 2 by 2. Okay, so let's multiply this. When I said it's rows of the first one, here's row 1, here's row 2, times by columns of the second one. Here's column 1, here's column 2. If I multiply these, it's essentially just a game of battleship. If you want to enter this value right here, it's row 1 times column 1. Multiply row 1 by column 1. What we do is we multiply the first 2 entries. 2 times 3 is 6. And we add it to the next 2. 1 times 4. We get 6 plus 4, also known as 10. And then we move on. Let's say I want this one right here. That's row 1, column 2. We're going to multiply row 1 by column 2. Multiply the first 2. 2 times negative 1 is negative 2. Plus multiply the other 2. 1 times 2 is 2. Then we move on to the bottom ones. Same concept. Row 2, column 1. I need row 2. This one right here. I want to multiply by column 1. 3 times 3 is 9. Plus 0 times 4 is 0. And then the last one. Row 2, column 2. Row 2 times column 2. Multiply the first 2. 3 times negative 1. Plus multiply the other 2. 0 times 2. And then we get our answer. 10, 0, 9, and negative 3. And that's how you multiply matrices. It's rows of the first times columns of the second. Before we move on, I'm going to do a few examples. Let me show you an alternate way that's the same idea, just it displays it a little easier, I think, for most people. Let me do that right here. I'm going to do the exact same problem, just to display it a little bit easier, hopefully. This alternate way is that we're going to leave that one there, multiplying 2, 3, 1, 0. And we're going to multiply by this one. I'm going to put this one a little above here. A little disjointed. 3, 4, negative 1, 2. The one that's first, right normally, and the one that's second, right above it. Then we're going to do this. We're going to separate. Everywhere there's a space, we'll put a little line. I'll put a line here also. If you notice, I get a little 2 by 2 matrix. And it just tells you which ones you should multiply. This first entry right here, I'm going to multiply the first 2. 2 times 3 is 6. Plus the next 2. 1 times 4 is 4. We're doing row 1 times column 1. For the one right here, I'm doing row 1 times column 2, which is the same thing we did right there. Negative 2 plus 2. For the one right here, it's row 2 times column 1. I get 9 plus 0. And for the one right here, row 2, column 1, negative 3 plus 0. and I get the exact same answer. Just this is why it works. It's we're doing the exact thing. It's rows the first time, it's columns the second. This makes this a little easier to see. That's the idea. Let's do a couple of examples. We're going to do this problem. I'm going to multiply 2, 7, 1, negative 5. Actually, I should check, but I know these are both 2 by 2. They do multiply. Negative 6, negative 2, 3, negative 4. And then everywhere there's a space, I'll put a line, my dividers. And then I get my 2 by 2, and all I do is multiply the corresponding part. Row 1, column 1. The key thing, keep in mind, you multiply the first two, then you move on. 2 times negative 6, negative 12, plus move on to the other two. 1 times negative 2. We do the first two, move on to the next two. That's how we do this. I'm going to do the one right here. Multiply the first two. 2 times 3 is 6. Move on. 1 times negative 4 is negative 4. Down here, move out the first two, negative 42, and then you move on to the next two, 10. And you're always adding. The last one here, 7 times 3 is 21, plus 4 times 5 is 20. We get the answer of negative 14 to negative 32, 40. Negative 14 to 32, 41. I'm going to do the same thing here, but all I did was switch it. In normal mathematics, when you switch it, 3 times 4, it's the same thing as 4 times 3. But not in matrices, because in matrices, you're multiplying the rows times the columns. If you switch it, you're multiplying the rows of the second one times the columns of the first one. It totally changes the mathematics of it. Let's do this one real quick. 6, negative 2, 3, negative 4. I'll write this one up here. 2, 7, 1, 5. Where the spaces, draw lines. On this one right here, we're going to multiply the first two, negative 12 plus 21. Over here, multiply the first two, negative 6 plus second two, 15. Down there, first two, negative 2 times 2 is negative 4 plus 8. And the last one's negative 2 plus negative 20. And in this case, I get 9, 9, negative 32, and negative 22. Very different than the one I got over there. Matrices are not commutative, unlike normal mathematics. They're a very special property, but A times B does not equal B times A in matrices. These are not the same. Keep that in mind. Matrices are special. Let's do a couple more examples with different numbers, not the same. Let's see here, I do want to check. This is a 1 by 2, 1 row, 2 columns. And this is a 2 by 1. So they can be multiplied. And do the same thing. 9, negative 2. Put this one up here. Negative 2, 6, 4, negative 7. Everywhere's a space, which is only right here, really. And actually, I should have done this. Sorry, I apologize. We should get a 1 by 2. We should get 1 row, 2 columns. 1 row, 2 columns. Perfect. We're going to multiply the first two. 9 and negative 2 is negative 18. Plus, multiply the next two. Negative 12. Move on to this one. Multiply the first two. 9 times 4 is 36. Plus, negative 2 times 7 is 14. We get negative 30 and D. That's all it is. Check if you can multiply. If you can, it's row times column. Move the column one up. Move the second one above. And then draw a space so it lets you know what things should be multiplied. Multiply the first two. Move on. Multiply the second two. Let's check a couple more. Let's see, this one is a 2 by 1, and this is a 1 by 3. Another one we can multiply. Yay. Doesn't rewrite it. Negative 1, negative 10, 1. I'm forgetting, I should check what we get. We're going to get a 2 by 3. So we should get a 2 by 3 matrix here. Where there's a space, put a line, the divider, and look at we get a 2 by 3. This is actually a little easier. Look at that. I just got to multiply these two. Row 1 times column 1 is negative 1 times 9, 9. Negative 10 times negative 9, 90. And negative 9. Multiply those two, negative 6, negative 60, and 6. There we go. I put a matrix. That's the answer. The next one. This is a 2 by 3, and this is a 2 by 2. The first thing you gotta check is see if they work. This one actually doesn't work. They don't match. Can't multiply. Those are our favorites. Less work. This one right here. I want to show you how to do your calculator. I'm bring out my calculator again. And all we're going to do is multiply them in our calculator. So let's type them in. First thing with a matrix. You can go all the way to edit. It's easiest to route over the ones we have already. Trust me, it's not worth trying to erase them. This first one, it's a 2 rows and has 4 columns. 2 by 4. We're just going to type it in. Negative 3. So that's in. And I'm going to go to my other matrix. Go back and edit the other one. This is a 4 by 2. And actually, before I even do this, I should check if I can multiply them. They can be. 2 by 4. This is a 4 by 2. They do multiply, and you get a 2 by 2. I should do this first, because if they can't multiply, my life's a lot easier. Negative 3, negative 7, 1, 2, 0. Hurrah, I gotta type it in, apparently. And then 0. If I want to multiply these, all I gotta do is go to second matrix, like the first one, times second matrix, like the second one, and you get an answer. Negative 16, negative 1, 6, and 10. How easy that is. And by the way, if we switch it, I mentioned before, if you switch it up, If you do it the opposite way, you don't get the same thing. You get a totally different matrix. If you switch, you got a 4x4 instead of 2x2. AB does not equal A. By the way, how am I going to make sure that you don't just put in your calculator all the time? Well, first I'm going to ask you nicely. But second, I'll do something like this. 3A, 2, 1. I'm going to multiply that by 2, 3, x, 4. For this, you can't put in because they're variables. You have to do it by hand. You have to go 6 plus 6 is 12. Here, you're going to get 3x plus 8. Over here, you're going to get 2a plus 3. And over here, you're going to get a times x is ax plus 4. That's how I make sure that you can't use your calculator. I'll just put some variables in there, and now you have to do it by hand. I know. I'm a jerk. Been hear that my whole life. Last problem. Application problem, as always. Let's look at this one. The table shows the number of people registered for aerobics for the first quarter. Here's Quinn's gym. You can see aerobics, this is how they buy their tickets. Are they going paying each class, or do they take a little 11 class pass, or do they go unlimited times? So aerobics and step aerobics. The gym charges the following registration fees. Class 5 class is $165, 11 class pass is $110, unlimited is $239. Write a matrix for the registration fees and a matrix for the number of students. Okay, the number of students. Let's do that first. Aerobics and step aerobics. 35, 28, 32, 17, 18, and 12. This is class 11 and unlimited. Just keep in mind this is a 3x2. So in this one, they want you to write for the registration to make sure I can multiply. I'm going to do a 1x3. What we're going to do is class by class is 165, 11 class pass is 110, and then unlimited pass is 230. This is how much it costs. This is a 1x3. Then right here it says find the total amount of money the gym receives from aerobics and step aerobics registrations. What we're going to do here is we're going to multiply these two. I'm going to multiply this by this. They match. So I need to multiply them. I'm going to get a 1x2. But also, what you keep in mind what that 1x2 is. It's 1 row, 2 columns. With my 1 row, I'm taking the row from this guy here. My row is going to be the money. How much it costs. How much money I make. And the columns I'm taking from this guy here. And the columns here are for aerobics and step aerobics. When I multiply my calculator, I'm going to get the rows of the first one, which is the money, and I'm going to get aerobics and step aerobics. This is one way I showed you where matrices are useful. To put in a matrix, put in your calculator, give an answer, and tell you what your solution is. This is how Excel works. And to save you some time, I already typed it all into my calculator, so the 2 matrices are there. I'm just going to multiply them, so that one, this other matrix. And we get 13,597 and 9,000. So around 13,000 and then 9,000. That's how much they make for each class. Aerobics is getting more money than step aerobics. Anyway, that's a lesson.